Video lesson 14.3, chord segment lengths. So we're going to focus today on specific line segments known as chords. So first, let's just define what a chord is. Let's write it up here just so we have a little bit of space. So chord, and that is simply a line segment that intersects a circle at 2 points on the edge of the circle. So if you look at this example here, I have two examples of a chord. First is your most common version, and that would be this one on the top. So it goes from here to here, right? I'll highlight that one in green here. That is a chord, right? Touches the circle at 2 spots, and it's inside of your circle. Now, if I was to extend that line segment, right, outside of the circle, it would then be a secant line. But the portion that's within the circle is referred to as a chord alone, all right? So that's your definition of a chord. So just any line segment that touches the circle twice and is inside of the circle is a chord. So the other one here, and I'm going to highlight this one in blue, this here is also a chord, right? Touches the circle twice. But if it crosses through the center, then that chord has a special name, and that's the diameter, like we've used before. So a diameter is a chord, right? So all diameters are chords, but not all chords are diameters, okay? So that's important to know. But again, as long as it touches 2 points on the edge of the circle, then it's a chord. All right, so 2 properties that come along with chords. The first one is that if you have the diameter and a chord intersecting, they're going to bisect each other. Sorry, not each other. The diameter is going to bisect the chord. All right, so in here, right, with this situation, so if the blue line is a diameter, which I'm telling you that it is, right, then the chord here has been intersected if it is perpendicular to the chord. So if this is in fact a 90-degree angle, right, then this chord gets broken up into 2 equal pieces, aka where it intersects would be a midpoint of that line segment. So if I called this, for example, line segment AB, and let's just call this one for argument's sake CD, right, then it is, we could then say that if AB is perpendicular to CD, then we'll call this M for midpoint. So AM would be congruent to BM. All right, so that's an important little fact. It's helpful to know, but again, it's all dependent on whether this diameter and this chord are bisecting each other, and that is if it's in fact perpendicular. So that's the key part there. It has to be perpendicular. The other chord property, not as common to find, but if you do have it, it is very useful. But we'll just want to kind of like show you at least about it. If you've got 2 chords that are congruent to each other. So if in this example, AB and CD, if these are in fact congruent to each other, if the center, right, from here, so I've got from O being the center of the circle, these 2 segments here, if they're going to the midpoints of the chords, and as you can see, they're right angles, they're perpendicular to that, then they are also going to be congruent. So this, like I said, this is not as common to kind of see on a normal basis, but again, from time to time, if you have this, it does make it helpful. So basically what it's saying is that if AB, line segment AB and line segment CD are congruent, right, so I have 2 equal chords, right, if I was to draw a line segment from O to the midpoint of each of those segments, all right, and they're perpendicular to those chords, then these are in fact congruent themselves. All right, so like I said, not as common, but it is, if it does arrive, it is usually helpful in being able to try to name one of those things. All right. All right. Now, the to me, one of the most important parts is this next one, and this is the application of chords. Like what happens when chords are interacting with each other. Just like how the secant lines and the tangent lines had special relationships when they started to intersect each other, chords have the same thing. So, in this one, and I'm going to highlight these again. So I've got the blue chord and the green chord here. So in this scenario, right, if I was to take these two things, you could make a proportion here, right, utilizing the portions of the segments themselves. So just like this, instead of having a crazy, formula looking thing with, the product of the A, B, and C, and D, I personally just like to write it out in terms of its parts. I think it's a little bit easier just to kind of think of it in words. So if I consider the green one to be the first line segment, right? Part A, we'll call it, right? This part A, times the second part of that one, which we'll call part B. So the product of those two parts, so in this case A times B, will be equal to the second segment. We'll call this part the first part, or in this case C, and the second part, which I'll highlight here, we'll call part D. All right, so if I take those two things and I multiply them out, so all I've done here is I've taken A, I'm going to multiply that by B, and that will be equal to the product of part C times part D. All right, so that's what that means. All right, so that's a special relationship that chords have with each other. So that cross product is true. Again, it comes out of being proportional to each other, but it only works if you have two intersecting chords, right? Their products are equal. So it's important to remember that it's their products. You have to multiply them, okay? So let's jump to a example. I think it's a little bit easier to see when you have it in an example form from here. So I identify the fact that I've got two chords, all right? Again, here's my first chord, here's my second chord. It doesn't matter which order you do them in, all right? But we've got our parts here. So right away, two chords, again, just like I said with the other ones, when you see those types of things, you got two chords, right? You're going to think part times part equals part times part, right? So take the part of each portion of the chord and you're going to make a product of each of them. So I'm going to do 4 times 12, so this part and this part, and I'm going to say that product has to be equal to this portion and this portion of my other one, so 6 times x. And now it's just a matter of simplifying this equation. So at this point, just simply multiply. So you've got 4 times 12, right? What is that, 48? Is equal to 6 times x, which is just 6x. So if I divide that each by 6, we're going to get x to be 8. And again, you want to just make sure you answer the question. In this example, it just simply says x is find x. So x is our answer. All right, x is 8. And you're done. All right, that's your product. Again, like most questions, a lot of times they might ask for other things or other parts. So you just obviously go back and answer whatever portion of the question you need. But it's all about the setup here and being able to do it. So again, simply multiply each part of one chord, set it equal to the other product of the other two parts of the chord, and then solve for whatever you're missing. All right, let's look again at another one. So here, I've got DE is 11. So this is 11. BC is 10. So they tell me that BC is 10 and DF is 8. DF. Oh. So this part was 11. This was 8. All right. So find FE, BC, FC. We've got a lot of little parts, so we gotta find it. Okay. So, looking here, right? We know the portions of this here. So we've got 2 chords, right? So we know the whole thing here is 11. So if this part's 8, if I just simply say 11 minus 8, that's going to get us this portion, which they're telling me would be 3. So FE in this case, so FE is just simply 11 minus 8, which is 3. Easy enough. Nothing crazy there. All right, so to find the other part here, all right, not as simple because I don't have one of the parts. So if we call one of these parts X, let's call this one X, right? Then this part, so if BF is X, then FC would be whatever X is taken away from 10, just like we did on the other one. So this is going to be 10 minus X now, right? That's a way for us to represent FC in terms of X, since we don't really know what X is. But I'm doing that so that now I can create a proportion out of their 2 chords. Right? So I can now say that the parts of DE, so 8 times 3, has to be equal to the parts of BC, which is X and 10 minus X. Once I have this form, now I can just utilize my solving equation skills and be able to find X. So the hard part here is noticing that I have to create this representation for BC and its parts, right? They don't give it to me as directly as they did in the other one. All right, but once I have that, it's all about solving, distribute, and then combine like terms and everything. So I've got 24 is equal to 10x minus x squared. I would move everybody to the left. So if I add that over, I get x squared. Subtract this over, I get 10 minus 10x. 24 stays on that side, all equal to 0. I can now factor, right? X. I want the factors of 24 that are going to add or subtract to get me 10. So let's see, we've got 2 and 12. All right, signs have to be the same. So that one's not going to work. 3 and 8, 6 and 4. That one will work. So we'll go 6 and 4. So we're going to have a -6 and a -4. Split them up. X equals 6, X equals 4. All right, so we look at this part. We say X could be both of those things. All right, so does one of them cancel out? Now, they're both positive, so that's fine. If one of them was a negative, then obviously that would reject out because X represents the length of a segment, so it couldn't. So how could it possibly be both? Well, remember, we arbitrarily picked BF to be X. We could have done FC to be X. So really, in this case, if I called, X4, then this one's going to be 10 minus 4, which is 6, so and vice versa. So it doesn't really represent both scenarios. In this case, I generally say just go with what how it kind of interprets based on the picture. So in this example, I would say that BF, right, would be 4, because based on how it looks, BF would be 4, and FC would be 6. Again, I know, as I said a lot of times, you don't want to just assume, but that X has to be one of these, can be both of these. So based on that, it's 4 and 6, and again, otherwise, vice versa, it would be reversed. And if you were doing something and in one way didn't work out, then you can just switch it to the other. But for these purposes, this is fine. You can just, say that each of them is the part. The important part is that you were able to get to the X values completely. All right, I did want to show just one little quick one here. I'm not going to go into too much craziness with this because, like I said, it's not one that's as intense or as crazy as the other ones, but they're saying that if AF and AG, if these two segments are equal to each other, right? If they're equal, and they're saying that BC is 22, what is DE? So it basically comes out to be, it's not a good line. What is this? All right, from here. Now, again, this is all a big thing, and I purposely left it off because I wanted to make sure that I highlighted it. So without this piece of information that I'm about to say, you can't do this, right? At the moment, just looking at this, there's no real way for me to do this, at least not with the geometry, the knowledge and that we have at the moment, to do it. But if I just simply said, oh, hey, this segment is perpendicular to this chord, this segment's perpendicular to this chord, all of a sudden, now I've got a scenario that I'm like, oh, wait, okay, that means that in order for these two segments to be equal, they have to be intersecting the midpoints of these chords, and those chords must be equal. So then I could say, well, DE is in fact 22. So like I said, you need a lot of specifics in order to utilize this fact, but it's one of those things, if you do have it, then it becomes helpful. But again, like I said, not as often or as common when doing it. All right, last but not least, let's just go through this one real quick. If AB is 8, so if all of this is 8, what's the length of AC? So we got to go back to the information that we were given. So in this case here, I'm told that AB and DE are perpendicular. So I'm going to just highlight these pieces right now real quick. So there are my two parts. The green one, the green line segment, right, is from D to E is a chord, but it goes through the center of the circle, so that's a diameter. And it's saying that it's perpendicular to each other, like so. So by definition, if I have a diameter intersecting a chord, right, that is perpendicular to each other, then this gets split into two equal pieces. Therefore, AC is going to equal half of AB, aka 1/2 of 8, which is 4. What's the, if DC is 2, what's the length of AB? So if they're saying if this little portion here is 2, right, what would the length of AB be then? So again, we're ignoring the first part. All right, they're saying here now, what would this be if this part is 2 from there? So in this case, right, oh, actually, I'm sorry, that's a typo on me. What's the length of CE? Sorry, not AB, that's the one from above. We already know that part. CE. So what is all of this part, right? So again, if I set it up here, it's two intersecting chords, I can do it as its parts. Now, you just got to be careful. The parts of AB, as we have already indicated, is 4. So it's going to be 4 times 4, right? Because each of these is now 4. And we're going to multiply by the parts here. 2 and all of this. Now, if all of this, right now I'm going to call X, right? We can call that all X. And then it's just simple one here, right? I've got 16 is equal to 2X. So X is 8. So all of this is 8. All right, so CE equals 8. And you're done. If that's all it's asked for, then you're finished. Now, what if it asks for like something like CP, right? You have to recognize, like, how do I break up 8 then? And what's just this little part? And I'll highlight that in orange here. Like, what is just this little part, right? Now, this is an extra part, but it's important to know because a lot of times they do ask things like this, especially when you're given a diameter, because I can figure out the other piece, right? We know that from D to P and P to E, they have to be equal because P is the center. So that the rest of these would be a radius. So I could, in fact, figure out what the other portion is. with that. All right, so that's one thing that we could do. The other thing that can sometimes be asked, and it is a little bit more extreme, but it can be asked, and I'll do it in yellow here. If I do know that part and I know this piece, they could say, hey, what's the length of, for example, B to P? Well, that segment, it's a radius, right? So you could have that. You can know, if you know the radius, then you know the length of that. If you don't, let's say you know the other two pieces here, like this was 4, and you know what this one is, CP, you could use the Pythagorean theorem to find the third, because we know it's a right angle. So there's a lot of different ways you can do it, and it just all depends on what information is given to you. But it's important just for you guys to be able to see it and understand and know that it's a possibility. And as we go through these questions, you'll see sometimes they utilize that information, sometimes they don't. Okay. Hardest thing about these is the diagram and interpreting it. Right? A lot of information is given to you in the diagram, not necessarily in the words or the question. It's all about the symbols and the knowing the definitions of the different parts of the figures. Right? So take the opportunity, go over any questions in this video that you may need more work on, and then utilize the practice problems for better understanding.